Hi guys, thanks for tuning in to another episode of Nuggets News. Today we welcome back a special guest, and that's Colin Cantrell, one of the founders of Nexus. So how you going today, mate?
Yeah, pretty good. How about
Pretty
yourself?
good. I'm really excited to jump into everything you guys have been doing. You're getting ready to launch that 3D blockchain, and everyone loves the concept of a decentralized internet with cube satellites and
hmm
whatnot. Very futuristic. So, Colin, to get people up to speed, what has been the focus for the past 12 months, and where are you guys at now?
Tritium, essentially. Just a little bit of background. We're deploying what's called the Tau framework, which is three updates called Tritium, Amine, and Obsidian. Part of the design of them is to upgrade a legacy blockchain using UTXO model, kind of like Bitcoin, into a fully capable three-dimensional
Yeah.
blockchain with smart contracts. So Tritium is the first step. The reason we broke it out into three different steps is it's a lot of changes, and we want to take these changes very pragmatically and slowly. So Tritium is the very first step of this. That essentially it creates smart contracts, but not smart contracts in the way that people are used to, where people programming on a blockchain is considered a smart contract. This is actually a contract between
Mm.
people using Boolean logic. So what that means is it's if this happens, then this, and you can do this if this or this is true, or if this happens. So that's kind of how natural contracts work as far as legal language
Yeah.
contracts. And so that's kind of the way we designed it, because we started, or at least started the design of the Tau framework in about 2016,
Mm.
and then really started developing it in 2018. And a lot of those 2 years we actually spent talking to community, talking to crypto people, talking to Fortune 10 to Fortune 500
Yeah.
businesses, and just understanding what their business models are, how they think blockchain could affect it, and really drilling down to what it is that people want from a blockchain. And that research was really important in molding and shaping the way that our protocol is designed
Yeah.
now.
So really simply for
And
people at home, Nexus is trying to build a scalable blockchain to solve a lot of the issues that other blockchains are running into with a sort of proof of stake
yeah,
model. But the contracts and
yeah,
giving people real world applications from the get go is really important.
yeah. And scalability to us is not a feature; it's a
Yeah.
requirement. So, I mean, in order to have the system, I mean, scalability is just something that should naturally come with it. The biggest thing is to make blockchain, demystify the blockchain for people,
Yeah.
right? So that it's something that people can feel and touch and interact with in a way that doesn't feel like it's this esoteric, super powerful, something going on. I'd say in certain businesses, especially from the 2017 hype bubble, it says you can't build magical unicorns on a blockchain.
Yes.
There's certain things the blockchain can do and certain things that it can't do. And making that really practical and pragmatic and demystifying all of these, we're going to do everything on a blockchain, and really drilling down to what's important for a blockchain to do and what's important for it not
Yeah.
to do. And how do we interweave blockchain functionality with our existing internet? And how is that going to really make the internet a safer
And
place?
I think that's probably never been more important with what we see going on in the world today. But I guess I want to say congratulations because Steve Wozniak, who's one of the co-founders of Apple, partnering up with you guys on a little passion project, that in itself is just great recognition. What you've been building is going to actually
Thank
work.
Yeah. It ended up working pretty well. And part of the reason that we actually were able to develop that relationship is that we did demystify it so that they could clearly understand how it exactly works and what it is that it's going to do. So that's been a really, really exciting project in education, because it's not only something that builds recognition and whatever, but it's going to do a lot of good for kids and people in general in the educational system. So we're really excited about that. Really excited to be able to announce kind of the more full spectrum of this project over the next, I think, 4 or 5 months in March, I believe, next year.
And as we're talking about in the pre-interview, getting kids passionate about tech can, it can be boring, but I think the world we're living in now with internet and censorship, and they're sort of coming attuned to what's going on around them.
Yeah.
So the idea of a decentralized internet without censorship, I guess it has its issues, as we've seen with other projects when it comes to filtering out the bad guys and the really bad stuff, doesn't it? But it's never
Yeah.
been more important in today's world.
Yeah, and I guess the internet was meant to be kind of a democratized system. And this is where you always get into this very difficult philosophical struggle when you start talking about decentralization, and even anonymity and privacy as well. How do you prevent, child porn rings? Well, at the same time, how do you allow people to freely exchange information with one
Yeah.
another? And that's kind of part of the DAO technology that we're developing too in Tritium++ is well, what shouldn't the network have the ability to discern what it wants to be running and not? So in a sense, if you can, instead of having it be kind of a singular authority to say, hey, this is unacceptable, what if it becomes kind of a global consensus that's able to kind of make some of these decisions? And that's kind of part of this DAO construct that, I first envisioned in 2016 is developing these voting structures, and the voting structures themselves can have some sort of influence over the way the network relays information.
And is that a 2/3 majority, or how does it work if the majority of people say that this sort of child porn, this is bad, we need to stamp this out of the network? How does that all work?
So the way that we found, and this is kind of a big issue that we've seen with democracy, is you have this mob rules mentality, right? Where you're not necessarily applying a weight or a quality to each specific vote. It's just one for one, right? You're one person, I'm one person, and then that's 1-to-1, where somebody may have, for lack of better words, a more valid opinion or perspective based on their educational background or something like that. And that's kind of the foundations of what we consider kind of a meritocracy, where people that develop merit are equally rewarded for that merit. And so then those people that, are in a more meritable position have generally a little bit more influence than, others that, are just kind of like elite to the system.
And that's something that I wish our government would run more. I would love that if the health professionals were making decisions about the healthcare industry. So it's great that you guys have done that.
Yeah, exactly. Yeah. And so the DAO is broken into voting groups. With Tritium++, we have Tritium that's being released on the 5th and then activating on the 11th. And then we have a post-Tritium hard fork called Tritium++ that's going to be unlocking the DAO. This DAO is only going to have 2 voting groups, but the full-fledged DAO, which is going to be unlocked over the Tau framework, is going to have 6 voting groups. Because if we look at, a prime example, the block size debate. So you have regular users, you have miners, you have traders, you have business owners, you have exchanges, you have merchants, right? You have all these different people, but really fundamentally the decision came down to the developers and the miners. And a lot of people, I saw a lot of petitions being signed to increase the block size, and it never really happened. Granted, the developers did have valid opinions and valid perspectives on that. You can't indefinitely increase the block size. It's just architecturally not going to work. And so they started going to layer 2 scaling solutions. But I think a great majority of the Bitcoin community still was unsatisfied with those decisions because their voice was not heard. And so what ended up happening is we have splits. We have, Bitcoin Cash, and then Bitcoin Cash had its own philosophical differences to Bitcoin SV, and then even, back to the foundations of Ethereum with Ethereum Classic and Ethereum, right? So these forks happen because there's massive governance issues. And so if you think about it of people being weighted according to their resource contribution to the network, but those being grouped together in a single voting group that has one vote together, then you have developers having one vote, and you'd have, let's say, ambassadors making another vote. You'd have miners having another vote, stakers having another vote. And together their majority, right, which would be, 50, 60% majority, would then go through and actually, create that weight of those choices. So the way that we've designed our DAOs, it's kind of like, think of it kind of like, lack of better words, like having a stack of poker chips, right? So you have a certain amount of stake and a certain amount of trust from staking. And just think of that as a stack yay big. And you can take a percentage of that and allocate it to, let's say, one embassy, and another percentage and allocate that to another one. And so your decisions can become percentage based, where you have 100% to work with, and you can essentially choose how you allocate those percentages. So that by the time the final tally comes through, this original DAO that we're developing is just for the funding mechanism. That determines your percent of the funding that you actually receive. So over the average of everybody voting and saying, well, we want Australia to have 50% or 40%, and all of that average together, let's say it ends up being 35%, then that creates the second voting group, which is the ambassador voting group, which are allocated, right, from those percentages. So
I was going to say, is this all going to be ideally very easy to do from the Tritium wallet for people to vote? Because I know that's something that a lot of, even EOS, I see them having real issues, people having to create an account, create that wallet, and then vote and whatnot. It's still not easy to do, is it?
Yeah. So this is going to be pretty simple. I mean, people that stake, normally that's going to be essentially the people that stake are going to be the ones that have the vote. To start, at least for this first voting group. So it'll just be a simple new module in there, and it'll pop up and it'll just say, hey, how do you want to locate your percentages? You'll be able to vote at any time. So it's not going to be this, tally voting time that everybody goes and rallies around. It's going to be a consistent thing. So if you see something somebody does, you can just change your percent. So it should just be as simple as saying 20% there, 30% there, 50% there, and then you're done.
Fantastic. And is there any reason, I know a lot of big projects have found it really hard to integrate with Ledger and Trezor, but you guys have seemed to have a real focus on building a really good quality desktop wallet, or what's the thought process there?
Yeah. So the way Tritium Protocol works, and this is part of the usability, making it easy. You know how you have to have a Trezor, you have to store all your private keys, you have to make regular wallet backups. Even the loading up of a desktop wallet can take ages. I don't know if you've used some coins that
yes, particularly back in the day.
Yeah. So basically the way it works with the Tritium Protocol is it's a decentralized login system. So you have a username and a password and a PIN number, and you can just log into your wallet, and boom, you have all your coins. And you don't have to store them on a Trezor. You don't have to store them on a Nano. You don't have to make wallet backups. You actually have no more wallet.dat file. So there's nothing to lose, right? And then essentially it works by kind of unlocking a space. So you own a space in mathematical hyperspace. Let's just consider you have the mathematical universe, and there's a certain space that you own, and that's kind of where your credentials are. And when you have your login credentials, it allows you to deterministically create the key to that space to unlock that space. So that you're essentially storing your keys in the mathematical hyperspace is kind of what I like to say. So it remains decentralized, but it's also extremely secure and more usable, because the desktop wallet right now, you'll log in, but when we start getting to more mobile wallets, we can design them, especially the interface, similar to your mobile banking app, right? Which you have a username and a password and a PIN number. And that's going to be really familiar for people, because they're not going to be used to storing all these keys and having all this stuff. And that's a huge barrier to entry to cryptocurrency.
Yes. I think
just managing those keys and the fear of losing those keys. Right?
I think that's something that people have a harder time getting their head around, that concept that their Bitcoins don't live on their phone or their computer or even their hardware wallet. It's the private key or the right to access and interact with the blockchain that lives on there. So you guys are just kind of taking a different take on that.
Yeah, and we're making it so that it'll streamline in, and this goes into the development, right? So I mean, let's say you have a decentralized application. And you have a bunch of users with this application. Well, if you use kind of a more legacy protocol, then every one of these users would have to have a key. Now, if you're talking about a business adopting this technology, is the business really going to make every one of their users actually have to store these private keys and then have a whole other mess of support inquiries if these people lose their keys? And it just is not going to work as far as like seeing more like widespread, applications. But what's nice about this is it can integrate in parallel with existing login systems. So they can have their login to the centralized database, but at the same time, signature chain access. And so you can parallel these with existing systems and basically piggyback on the existing login system and provide additional blockchain functionality without having to have this whole other, I guess, barrier of entry.
I was going to say, like at the moment, we see a lot of issues with SIM swapping and hacking and whatnot. So it's great to be able to give the ability for someone to maybe reboot if they lose it, but how do you guys go about that security and stopping people gaming the system to try and reboot other people's wallets and hacks?
So it's going to be very difficult to hack, especially we use what's called Argon 2. So this is a password hashing algorithm that requires a lot of memory and it's very slow. So in order to create one transaction, it takes you about 1 second in pure proof of work. Just to generate your keys, so that if somebody else wants to try to offline brute force attack, it becomes very, very difficult. I calculated it. If your username was completely known and your PIN number was completely known and you had an 8-character alphanumeric password, it would take 5 million years to try to crack it with a huge GPU.
And this is something that Nexus have always been, I guess, mindful of, was quantum resistance. And we've seen quantum computers a lot in the news lately. And for people at home, again, dumbing it down a bit, having these longer strings, the longer you make them, the harder it is to crack them, even if you do have a quantum computer.
Yep. And we use, the nice thing about signature chains too is it still uses public key cryptography, but what you're essentially doing is you're decoupling your account identifier, which generally is like your address, right, from the actual key itself. So every single transaction you create, you're actually using a completely new private key. So you're still using all of the security benefits of having private keys, but you're essentially generating these private keys deterministically with your SigChain credentials.
And this is the one-time key security model I remember reading to change up the public-private key pairs. Yeah.
And the nice thing about that is with Bitcoin, right? You create a Bitcoin address, you receive the Bitcoins, you're locked to that key, right? Ethereum, you're locked to that same key. With a SIG chain, at any time, you can change your key type. So we support non-quantum resistant algorithms such as Brainpool, which it still has a decent level of quantum resistance because your attack window even with a quantum computer is less than 5 seconds. But using, post-quantum cryptography is also a necessary thing too. So we have the ability to use what's called Falcon. Now, Falcon is a post-quantum signature scheme, so that if you want to secure your account a little bit more, you can use that Falcon. And that also, interesting enough, gives us very high scaling characteristics because the two biggest bottlenecks I found with scaling a blockchain is your database, right? Which is you're reading and writing from your disk, and your cryptography, right? Like I've maybe managed with Brainpool to get 4,000 signature verifications per second, which basically puts your maximum throughput for a single dimensional blockchain at about that. That's why we're seeing EOS and Ripple and all of them top out around 2,000 or 3,000 transactions a second. Even if they have a sophisticated network protocol or a new database, you're still going to be limited by the cryptographic bottleneck because elliptic curve cryptography, which is what most blockchains use, is very computationally intensive because you're dealing with really large numbers.
So that bottleneck's at around that couple of thousand mark you said. And the other big bottleneck, even for these chains, is the latency and the ability to communicate. Is that right? Or
the network latency is not as big of a bottleneck because we do have pretty fast links. When you start dealing with really large volumes, you start getting latency issues probably at about 10,000 to 15,000 transactions a second. But the biggest one before that is the actual database. So Ethereum, even if you uncap it completely, people have run the Ethereum virtual machine and only maybe gotten 150 transactions per second or contracts per second processed because of the disk, right? And the way that they index. A lot of the blockchains nowadays use what's called level DB, which was developed by Google. Bitcoin started using that in, I think, 2013. Ethereum uses that, but it's still kind of slow. It's not designed for a blockchain application. We designed a database called the lower level database, which I first built in 2016, deployed on the main network. And since then it's had a lot of improvements. That actually exceeds the speed of Google's level DB. So that improves our actual database bottleneck. So before that though, interesting enough, I'm saying about 3,000 to 4,000 signatures per second, which is the maximum transactions. But with Bitcoin, you could have multiple signatures per transaction. If you have a lot of inputs, it's one signature per input. So really, it's about 3,000 to 4,000 inputs per second, which an average transaction has 2 or 3 inputs.
And that's what we're seeing Bitcoin and other chains trying to experiment with now, aggregating signatures and small signatures. But it's interesting. A lot of people, again, they don't think about that bottleneck point of no matter what we're doing, it still needs to get written to the hard drive on all those people that are running nodes.
It's a huge thing, man. So with using Falcon, it does create more of a bandwidth bottleneck, a network bottleneck, because it's very large. The signatures, all post-quantum cryptography has really big signatures. I'm talking probably 1.5 kilobytes for a signature and a public key for Falcon, where your average ECDSA is about 96 bytes, including the public key. So it's a lot larger, but computationally, this is the cool thing about Falcon. I've managed to test it, 150 to 200,000 signature verifications per second with Falcon. So it's using very simple polynomials. So it's not that computationally intensive. So that actually lifts when you use Falcon our cryptographic bottleneck, which was really important because now on Tritium, just some benchmarks. I break Tritium processing into 2 steps called pre-processing and post-processing. So essentially when you receive the transaction, you have to go through the pre-processing. Pre-processing is done all in memory. Think about memory as just the
readily available.
It goes away when you turn your computer off, so it's not persistent, but it's a lot faster than a hard drive. Your hard drive stays there when your computer's turned off, but it's a lot slower to read and write from. So pre-processing goes all in memory, and we were able to get about 17,000 transactions per second in the pre-processing area. And then post-processing is when you actually receive these transactions on a block and you need to commit that to the disk and then do all the processing that way. Post-processing is 2,000 to 25,000 contracts per second. But we have our block size limited too. So, we're not going to be seeing those types of transactions per second, especially when you have 1.5 kilobytes per transaction, you're going to run into bandwidth bottlenecks.
So just zooming out a bit, Colin, for people that are saying, well, this is starting to get really techy. What are some of the real world applications of this? I know you guys have got a lot of NDAs signed, I've heard, but what sort of businesses and that are like looking at this technology and saying, this is really interesting, this is going to be more efficient for us in the real world?
We've had a lot of interest in supply chains. That's one of the actual big ones, especially in the business world, because you can do so much with supply chain tracking, right? I mean, there's an incredible need for it. Like, I mean, you have supply chains for just about everything in the world, I mean, from pharma to agriculture, to quality control for, different manufacturers. So that's been a really, really big focus that we've been seeing. And natively, by the way, the Nexus architecture works, it's a register-based contract engine. So just think about that as most cryptocurrencies use a stack, where just think about it as a stack. And then, when you need a value, pop it, and then you push, and it's just like that, right? It goes up and down. We use registers, which are directly accessible in a constant time. So registers are much faster. Every modern CPU uses registers. It's just a more efficient architecture. So ours is a register-based virtual machine, or contract engine is what we like to say, because it's, it has a virtual machine in it, but the whole thing is a contract engine. And so naturally, a register can become an asset or an object. And then this object has ownership attributed to it by that user. And then that object can be transferred to other people, right? And so that is the foundations of the supply chain right there, is the ability to transfer. So in the sense of being able to record and transfer assets, it functions as a supply chain. Even with, I put my car title on the blockchain, I can see the ownership history. That is a supply chain. So natively, our architecture processes supply chains very, very efficiently. And so we've naturally had a lot of interest. Plus, that's, I think, the low-hanging fruit for a lot of businesses and what they're looking at, because it's the simplest to perceive as far as the use case, and very simple to implement as well. So that's been a big focus. Education is another huge focus that we're working on. And then, again, the satellites and tokenization protocols. We believe that the tokenization systems, as we know them, have been very limited to just speculative assets, if that even. And we believe that there's a lot of actual utility that can be used from these tokens, such as, I won't go into too many details, but I'm working on a project here for a use case dealing with just supply chains in chain of custody, such as, they have cash on delivery, they deal with a lot of cash, they need to have an accountable party, something like that. Or you can even get deeper into seed to sale systems, which basically tracks a plant from the seed all the way to the sale. And we're using tokens.
So is that right in saying that these are new tokens, like ERC20s go on Ethereum? There are going to be non-fungible tokens and different tokens all issued on the Nexus blockchain?
They're fungible and non-fungible. So there's different variations of it. The fungible tokens are essentially, a fungible item is something that can be exchanged for whole with another item, right? Now, if you think about it, right, and tomatoes are fungible, are they not? So is corn. So is any other plant. So, if we apply this type of fungible token model to these specific, items, such as, I, grew 10 pounds of tomatoes. Now I can tokenize those tomatoes and have that token contract essentially associated with the identity of that seed and that plant, where it came from. And then when those tomatoes are sold, you sell some of the tokens associated with it. And those tokens can represent not just a store of value, but a store of actual weight of specific produce.
And just on that, we've seen oracles being the hot topic lately. So it's all good having this technology and having these tomatoes, but how does that data get from the real world, into the blockchain in a lot of these scenarios?
So that's where we start focusing more on the IoT devices. So essentially, what you can have, since you have a signature chain and it's essentially your account, the signature chain can be used for an IoT device. And this IoT device can be some sort of authenticated device that somebody purchases that can essentially take a weight of item and then create the tokens for it. So you're always going to be able to see the source of those tokens from that specific IoT device. And that's going to definitely help. And then you have the problem with IoT is, though, how do you prevent the IoT device from malfunctioning or being manipulated to create the idea that there's more tomatoes than there really are? Well, you simply do that just by having the verification. Well, I'm buying 10 pounds of tomatoes from you. You need to give me 10 pounds worth of tokens. Otherwise, I'm not going to buy them from you. So you have that enforcement from the original genesis of the creation of those tokens by buy the actual produce itself.
And with all the ID verification and whatnot, we can say, well, we know that it was Alex that put 10 kilos of rocks on the scales instead of tomatoes at that time. That was his ID, so we can start to see the system.
Yeah, and I mean, all you're going to have, see, the thing is, if you do that, you're only going to have rocks, right? You're not going to just go and sell these tomatoes without the actual physical produce. The tokens are only there as a means to track the ownership of this physical produce. So, you'll go and have a bunch of rocks and then a bunch of tokens, and then somebody's going to say, well, where's my tomatoes? You're going to say, oh, well, I got rocks, right? And so those tokens will essentially become worthless because there's going to be no physical real world asset that's backing those, right? And so when you create that, from the genesis to the IoT and then transfer through the supply chain, then you essentially have some sort of enforcement with regular people where those tokens just aren't going to be accepted and be considered actually valid unless there's some physical produce associated with it.
Cool. Well, let's get into the fun stuff. The cube satellites, rockets. Everyone loves talking about this sort of stuff in crypto. So the idea was for you guys to launch these little cube satellites for people at home. And from my reading, I believe it was you only need about 200 of these globally to have a good enough coverage to have a global internet. And launching, you can launch 10 or 20 of these at a time. So it wasn't overly hard to create that network. But I know you're saying that you've pivoted a little bit and you want to do this in a more decentralized fashion.
Yeah. So, I mean, this has been a long idea that we've been developing since 2016. We've gone through quite a few different models. At one point we were doing the galactic sky model with vector space systems and stuff like that. But now we've really shifted our focus because the question is let's look at the beauty of the blockchain, right? It's not only just a technological innovation, but it's a social innovation in the sense that it creates a game theory, right? That has incentive to do, specific things that contribute to the best of the network, right? So one of the parts of the game theory is I get rewarded for producing blocks on this network. So what happens? The blockchain builds itself, okay? In the same type of sense, we're applying these models, especially with the tokenization protocols, to satellites. So the golden question, I guess, that we're pretty close to answering, we'll be announcing more, how should I say it, specifications on this design plan, but it's going to be basically, think of it as open source satellite technology, open source operating system, all tied together in a software package that builds, how should I say it, a revenue if you run it.
Creates incentives for people to support the network. Yeah,
precisely. So what you do is you don't think about how are we personally going to deploy all these satellites. The question really becomes, how do you produce an incentive mechanism for people to build the network itself? Because then it's going to be a truly decentralized internet. And then the second question to answer, which is a question that's taken us quite a bit of time, is what is the value proposition of a satellite? Why am I going to want to put a satellite up there when I could just use a computer on the ground, right? Well, one of the big reasons is censorship resistance, right? The second is that you can't ever bring it down. It's a lot more difficult. You can go destroy a computer on the ground, you have problems. Now, the third is that they also have radiation hardening, depending on how much you do, and how expensive your satellite is, that protects them against, it doesn't completely eliminate, but it protects against, some threats like electromagnetic pulse or, problems happening on the ground that, could essentially destroy infrastructure. So we've thought of it as, okay, well, now, when we apply this into a satellite constellation, now how do we harness the power of some of these things? So we've kind of really settled on an idea of essentially producing a software, right, which is Nexus, which eventually is going to become its own operating system so that Nexus OS will be able to run on IoT devices and satellites, right? And then on the satellites, they're going to run through a light mode, right? So they're not going to have to keep the entire blockchain. But what they're going to do, and this is the nice thing about the signature chain architecture, is I can just send out a request to the network to download my signature chain, and I don't need to download the entire blockchain history. I can just download my sig chain. Your sig chain is like a personal blockchain. Think of it like that.
Okay.
So you can just download your personal blockchain, you have it, and then you have all the state that you need in order to create transactions or verify something else from some other person. So when you apply this then to a satellite constellation, it's saying, well, what's the purpose going to be? Why am I going to put up a satellite? Well, because you're going to be able to have, I guess, a more secure hosting situation that's going to be censorship resistant. Now, why would I deploy the satellite itself? Well, because I could earn revenue from running that.
Yes.
So what essentially is going to become is it's going to become kind of like an AWS, but rather than being a computational layer, it's going to be more of a verification layer. And it's going to use verification systems that we have developed, like called TNS, which is the Tau name system, which essentially that's how with Tritium Protocol. Anyway, and tell me if I'm going on too many tangents, but I'll circle it back. That you essentially can create a naming system.
I think people are pretty familiar with the Ethereum name service now. So a very similar thing by the sound of it, where I can send my coins to Colin Cantrell .nexus and things like that instead of the address.
Yeah, you do that, and then you also get DNS records in that too. So what we do then is you tie that directly in with the SIG chain itself, and then when you start doing copyrights, right? Let's say you have a line of copyright that is a metadata for a specific image, then that contains metadata that then loads from your site service, so that what you get is you get called, what we call anyway, the safe net or the alternate, where when I go to a website, I can verify all of the content on there is authentic. It doesn't have copyright infringement, and then there's no viruses on there because I verify that from the ledger itself. So you create a secure data verification layer that ties in with our TNS service, kind of similar to the ENS and how Ethereum works, to essentially prove the ownership of that specific domain. And then from that ownership, then you have the ownership of all the different assets that go in to provide that domain. And then you get the actual physical data layer from the satellite link, which means that this service will be accessible from anywhere on the ground, but it'll be accessible in a way that it can't be censored, it can't be brought down, it can't be destroyed. And so people will be paying for services for hosting their essentially web service on this satellite constellation, and that payment will go to pay the cloud or pay the hardware that's actually providing that service.
So what are the costs of these cube satellites and launching them? I know we've seen SpaceX come out with their Starlink project. So is that competition, or maybe once they've got the incentives, they might start to support the network? Or
I mean, they could potentially join the network, but I mean, they're more of a centralized service, even though they're saying that they're going to be providing free internet. I mean, there's no guarantee that it's going to be uncensored. And that's, I think, where a lot of people are looking nowadays. So I don't really consider Starlink too much of a competition, because we're not really competing with anybody. We're actually cooperating with people, and we're creating a cooperative satellite constellation and alliance. So the average cost of a cube satellite can be anywhere from 100,000 to 300,000. The launch can be anywhere from 50 to 100,000. So, I mean, realistically, you're probably looking at about $250,000 to deploy this one of these satellites. So in order for these to become a profitable model, then you have to develop a mechanism in order for people to get their ROI on it. So it'll be kind of synonymous to, hey, I'm buying mining hardware to mine on this network, and it's got this profitability rating, and I get to burn my revenue back after a certain period of time. The same type of concept, I think, will be applied to these cube satellites, so that people are doing it as a business investment.
So in a ballpark figure, off the top of my head, am I thinking 20 or 30 million is possible to have enough of an internet, or are we talking a factor higher than that?
Yeah, I mean, that's a pretty low ball figure. I mean, it's obviously going to take more time, and each one of these satellites have specific bandwidth constraints too. So if we're talking about like a global internet that's processing, global web services and everything, it's going to be quite a bit more than that.
These numbers are still small in the scheme of, WeWork being valued at $50 billion. We're only talking in the millions. So this, for cutting edge, space age technology, this stuff's still very doable.
Yep, absolutely. And it's going to be even more doable when there's a profitable model for people to do this, because then people are going to go raise money on their own to develop their own, subset of the constellation and improve the hardware. But fundamentally, they're all going to be running the same software client, which will be Nexus operating system. And that operating system will give them access to the incentive mechanisms. Now, this also ties in with our tokenization model, because the way tokens work comparatively to ERC20 or anything is they're not just speculative stores of value. They actually give you rights to revenue. So if I create, 1,000 tokens and I give 500 to you and 500 to me, because we go into a joint venture, the revenue for that can go and split automatically. So if somebody debits, 100 Nexus in, what'll happen is that debit will go into the asset, and then you will essentially have a proof, and I'll have a proof that we can claim half of that, right? Since you'll have 50% and I'll have 50%, so that you have joint revenue creation opportunities for people, which then if you apply it on a macroeconomic scale for this giant constellation, right, then people that essentially hold certain allocations to token can also get some of the revenue from people paying for the
I
service.
think it's in a lot of ways it is similar to Ethereum in my mind, whereas we're not going necessarily for this monetary value like Bitcoin. We're going for these network effects, the social good, all the different applications, the assets backing it, as well as lots of Nexus tokens locked up to stake and support the network. So that's kind of the way I'm looking at the model unfolding.
And it's kind of, I guess, Nexus, I guess the best way you could describe it in comparison, it's kind of like a blend in between Ethereum and Bitcoin, where Bitcoin's pure verification, only the Bitcoin token, and Ethereum's Turing complete. We're kind of in the middle of it, where we didn't go the Turing complete route because based on our years of talking with businesses, people didn't need it. The blockchain, we don't see it as a computer like the Ethereum people see it. We see it as kind of a verification engine. And to verify certain specific things. Now, the power of the Nexus, especially or the Nexus virtual machine or our contract engine is going to be very significant. It's an object-oriented programming language where Solidity is kind of more procedural. So we have some of the more modern programming characteristics of it, but I guess in a lot of different ways, there's a lot of different facets to it, right? So I mean, the whole network itself acts like one big giant computer. With different objects, and then you can have the verified computation, but it's all accessible through the API. So that's the other part that we made it very simple for everyday people to be able to use. You can create a token in 5 or 10 minutes with a simple API command, rather than relying on, this complex contracts and everything. So yeah, we're somewhere in between the two, and we're pretty sure we've struck that delicate balance between what's really valuable in each one of these systems and what's not so valuable, and kind of blend them together into be something that's really going to provide a lot of value to people. Because still the idea of smart contracts, even from very well-known tech people that I speak with, they don't believe that the promise of smart contracts has been revealed. And in some senses, it really hasn't been. We've just need tokens, maybe a few different services, and scalability issues. But the idea of contracts and the way that they should be, I don't think has been fully realized. So we're really hoping with this technology that people will be able to start to realize that. And we think it's really fundamentally comes down to how easy it is to use, because that's one reason, speaking of Steve Wozniak, that Apple became what it is they're easy to use. They take something complicated and make it simple. And when you can do that, that's the golden ticket. And we think we're pretty close to striking.
Fantastic, mate. Well, I think we've covered everything I wanted to get to today. It's been fantastic, and I think it's a big few months and a big 2020 ahead for you guys. So I'll put all the links to follow Nexus and Colin down below. But thanks so much for joining us today, mate.
Thank you very much.
Cheers, guys.